In section 2.1, we're going to talk about how to simplify algebraic expressions. So we'll have to know about what are terms and which are like terms and unlike terms, because the way we're going to simplify expressions is we are going to combine like terms. And then we'll also use the distributive property to remove parentheses to simplify expressions. And we'll end with writing word phrases as algebraic expressions and simplifying them. So, first of all, to understand what a term is. A term is made up of a coefficient, which is a number. It could be positive or negative, could be a fraction, could be a decimal. And it may have a variable, which is usually a lowercase letter, and that is raised to an exponent. So an example would be 2x to the third. That would be considered a term. Or negative 5x to the fifth. That would be considered a term. Or let's say 3x to the fourth minus 4x squared. That would be two terms. The first term would be 3x to the fourth. The second term would be negative 4x squared. So a term has a coefficient, a variable, and an exponent. And there might be multiple variables. And then also, here's our trick question of the day. What if I have x to the fifth? You know what? The coefficient for that term, there would be a 1 understood there. That's like 1x to the fifth. But we do not have to write the 1. You actually can write the 1 if you like. But most math people understand that that would be the 1 understood. The 1 is understood. Okay, so let's identify the numerical coefficients. For this first negative 5x, the numerical coefficient would be negative 5. For this term, the numerical coefficient is a positive 2. All right, so for negative y, that's really like a negative 1y, but the 1 is understood, so the numerical coefficient for that term is negative 1. And here we have d over 3. That is like 1/3 times d, because you multiply your numerators and you multiply your denominators. So the numerical coefficient for d over 3 would be 1/3. All right, so you go ahead and try practice 1, section 2.1, practice 1. Now, terms are like terms if they have the exact same variable to the exact same exponent. I'm going to say next power or next exponent. So here we have 7x, that's an x to the first, and negative 6x, that's an x to the first. You know what? Those are like terms. They are both x to the first. Here for this first term, it's x squared y squared. Our second term, it's x squared y squared. But our third term here, even though there's x and y, these are not to the correct power. They don't have the exact same exponent. So these are not all like terms. These are unlike terms. The first two are like terms, but these three are unlike terms. And so this last one, this is negative 5 times a times b. When you see variables next to each other, that means we're multiplying them. And this is 3 times b times a. This is negative 5 times a times b, and this is 3 times b times a. Well, you know what? Multiplication is commutative, Another way to write that is 3ab. It wouldn't matter if the b was first or the a was first. Both of these are ab's. A to the first, b to the first. So these two terms are also like terms. So why don't you go ahead and try practice 2 in section 2.1. Now the reason it's important to be able to detect like terms is because the way we're going to simplify our expression is we're going to combine like terms. The way you combine like terms is you add the coefficients. You add the numerical coefficients. So here I have 9y and negative 4y. 9y and 4y, they are like terms, so the way I'm going to combine these is 9 minus 4 is 5, and keep the y. Here is 11x squared plus, and that's a 1 understood, 1x squared. 11x squared plus 1x squared would become 12x squared. All right, here we have three terms, a 5y, but there are no other y's in that expression, so we can't just drop it. We're going to bring the 5y down. There's nothing to combine with it. But here I have a negative 3x and a positive 6x. Negative 3 and positive 6 is positive 3. And we keep the x's. So we combined our x terms. And here's an m squared and a negative 1 m squared and a 3 m squared. They're all m squared. They're all like terms. So we're going to combine. We're going to add their coefficients. 14 minus 1 is 13. 13 plus 3 is 16 m squared. All right, so why don't you try practice 3. Practice combining like terms. And here, let's simplify by combining like terms. We just have, it's a little bit more complicated because we have constants here. All right, so we have a negative 7a and a negative 1a. Negative 7 and negative 1 is negative 8a's. And then my whole numbers, my real numbers, negative 2 and positive 5, is positive 3. Here I have an x squared and an x. These are not like terms, so this expression is as simplified as it can be. We can't combine them. That's going to remain 8.6 x squared minus 4.3x. And here I have 2/3 x minus 2x. They're both x to the first, so I can combine. So what is 2/3 minus 2? You can do that on your calculator, or if you want to do it longhand, you are allowed to use a calculator now that we're in chapter 2, but if we wanted to subtract fractions, they have to have the same denominator. So we would rewrite this 2. We're going to multiply that as by 3 over 3. That would be 2/3 minus 6/3. 2/3 minus 6/3, which would be negative 4/3. So again, on your calculator, you do 2/3 minus 2, put your answer as a fraction. Or if you like doing it by hand, give them the same denominator, but the answer is, when we combine our like terms, we get negative 4/3 x.